Hello, this is the supplemental lecture for the chapter 2 to help you improve the math reasoning further. So some of you might be stuck when seeing a couple of math questions and don't know how to start, and that's why I'm here, right? So when we see a problem, we have to know how to solve it, and then we've got to be prepared for that. And the tip is to keep practicing and then read the question carefully and know what the question is about. Tip number 2, you can tip number 2, one way to do well in math is to understand the language of math. Think about it in this way. Learning math is like learning a foreign language, like Spanish or French, right? So you have to know how the root of language works in order to do well. So treat math as a different language, which may help you feel better. So let's go over the 2.1 to 3. These are all the topics covered. And then we'll go over examples. Right, example number 1, divide. So whenever you see a question, there will always be a keyword for you to know what to do. And then if the expression is given, then we'll know how to solve the problem. So 7 over 9 divided by 13 over 5, and then we've learned that if we want to make a division, then we have to flip the numerator and denominators on the following fraction. And then the answer will be 35 over 117. Right. And then the question also states that write your answer in lowest terms. That means if there are common factors to divide these two numbers together, then you have to apply it. But it seems like there is no common factor for these two numbers. So that would be the answer in lowest terms. Right, remember, fraction only and no decimal. Next, multiply. That'll be much easier because you just have to multiply the numerators and denominators directly. And one thing you can do is to divide out the 3, and then you'll get the answer as 1 over 5. That's the lowest term. Right. And there's a tip for you to see how a fraction works at this point. So 1/3. So if let's say you have a pizza, and then I do know that this model is applied in some lecture videos, so I want to show you a way to visualize fraction. So let's say that we have 1/3 of the whole pizza remains, then the shared area represents 1/3 of the whole pizza, right? And then if you multiply the 1/3 by 3 over 5, that means you're taking the portion of 3 over 5 inside the blue shaded area. And then let me show you. So I'll change the color to red, and then let's say that, hey, we have more folks grabbing 5/3 of the pizza, which is that exactly the portion out of the blue. So it's a red portion out of the blue portion, okay? And then the answer is 1 over 5, and that actually represents the remaining red portion out of the whole pizza. So that part thus looks like 1 over 5 of the entire pizza, right? So that's how the fraction works. You have the first portion, and then you apply the fraction, then you take a fraction from the original portion and you'll get the portion out of the whole thing. And then for division, it works in a similar way when you approach the multiplication step. All right, example 3. Anyway, I hope that helps. Example 3. Right, now we are seeing a weird question. And then, right, I want to emphasize this one because it doesn't seem covered. Right, so if you have symbol like A or B, they're mathematical symbols. And then you can, and then they're symbols that can be replaced by numbers. For example, A, I'm making this up, A can be 2 and then B can be -3, etc. So, right, we normally use symbols for problem solving, and then the symbols is like a variable for you to plug in the given numbers if there is any in the problem. But since there's no number given, so we can treat A and B as numbers, as any number. And the way to solve a problem is similar. So let me show you. We flip the fraction when we divide, right? So the second fraction will turn into 2b cubed over 4a squared. All right. This is a quick version of problem solving. So if I divide out b with b cubed, then that power will be taken off by 1 and gives you b squared. And then if I divide out a squared with the a cube, then the a cube will turn into a to the 1. I'll write it down as b squared instead. Right, so that your final answer turned into a over 4 times 2b squared over 4. And then if you combine numerators and denominators, you should get 2ab squared over 16. Right, so that's how you solve a problem. And then let me show you another way to approach if you're lost in the first step. Right, so we have to understand what a cube is exactly, right? And then if you have a cube that equals to a times a times a, we're multiplying the a by 3 times. That's what it means. And then for 2b cubed, that would be 2 times b times b times b. And then for a squared at the bottom, that would be a times a, right? That's another way people solve a problem, but right. That method works well if you only have a few numbers. So let's say if you have something like a to the 20, then it's not efficient to write down all of the a's in this way, right? So that's why the first method is recommended. But for teaching purpose, I'll show you that, right? This is how a's are factored, and this is how b are factored out. That's how the a's and b's are divided out, which helps you approach the final answer, 2ab squared over 4, over 16. Okay. All right, hope that helps. And then the question states that you give your answer as a fraction reduced to lowest terms. Done. Oh, wait, no, not yet. Not yet. If I want to reduce to a lowest term, that I can divide out 2 and 4, so we will have 1 and 2. So that means the answer should be updated as, instead of having 2 over 16, we are going to have this updated simplified answer as ab squared over 8. And then the same thing happens here if you divide out the 2 and 4, and then that'll give you the same answer. Right. That's the lowest term. Example 4, add fractions. All right, so adding is different from multiplying, and we have to understand one rule in the math language, right? We can assume that, right? So let me put this down. Some people may assume that the answer equals to 3/15. That's not quite right, because the numerators and denominators are not additive in this way. Let me show you. Right, the way to do it is to find the common denominator first. So the common denominators will be 18, because a multiple as 3 will help you turn the 1/6 into 3/18. And for the second one, we have 2/9. That will be 4/18, because you multiply the numerator and denominator by 2, and that's how you get the answer. Right. Make sure if you think I go too fast, pause the video and then rewind and then check again. Right. The common denominators can be mixed in this way, and then this is when the numerators are additive as 3/4. And then you got the answer as 7/18, which is the simplest form. All right, here's the illustration. So we have a pizza. The first pizza has the portion of 1/6, right? So that makes sense. That looks like 1/6. And then the second pizza is a little bit tricky. We have 2/9, but it's still drawable. And then the 2/9 will be something like that. So let's say that this is 1/3, and then if we have that and that portion, then 2/9 will be, oh, no, I shouldn't do that. All right, let me just ballpark it. 2/9 looks like this portion. It's a little bit greater than 1/6. And how do you tell? We can check out these two fractions with common denominator, right? So that's 1/6, which is equivalent to 3/18. And the 2/9 is equivalent to 4/18. So that means 4/18 is a little bit greater than 3/18. So that's why the estimation here works. And then if you combine these two pizzas, you add up these two remaining pizzas, then you'll get the result with this portion, and then that portion added this one and that one. So just place two portions of pizzas together, and then the answer happens to be 7/18. Right. And doesn't look like 3/15 at all, because 3/15 is 1/5, which is much smaller. That's the way to tell you how the math works in a fraction. Okay. All right. Example 5, subtract. Subtracting is similar to adding. Find the common denominator first, and then the common denominator will be 12, because for the first fraction, you multiply the two numbers by 6, and then you'll end up having 13 times 6, which is 78. 2 times 6 equals to 12, and then you subtract that by 11/12, and then voila, you got the answer, 67/12. Right, the algebra shows that the answer is 67/12, and that is the reduced lowest term, indeed, because 67 is a prime, and then there's no other integer greater than 1 to make it divisible. Okay. Example number 6, evaluate. Well, in this context, evaluate means calculate. or right. You have to understand that language of math as well. Right, so we have 5/7 times 1/2 squared. Right, if you're not using calculate, so the goal is to find a numerical answer, right? And if you have the question like this, one simplest way is to deal with the fraction with power. So that would be 1/2 times 1/2, and that gives you 1/4. So you have 5/7 times 1/4, and you follow the rules of multiplication, multiply the numerator and denominators, and then you get the answer, 5/28. All right. Example 7, find the value of the expression. All right, again, find means calculate. It's not like finding something physically. I have several students being confused by that, so that's why I want to clarify. In a math context, find means calculate. Make sure you study and get familiar with all these keywords. And when you solve a problem, the first keywords is always the key, for you to handle the problem. All right, so let's see. All right, this is the part for you to pay attention to the order of operation. Right, we have 4 operations: adding, subtracting, multiplying, and dividing, right? So multiplying and dividing comes first, and then adding and subtracting come later. So that means when you see a division sign or multiplication sign, then you have to calculate that portion first. So we have 12 divided by 3, which gives you 4. And then when you do that, make sure the remaining portion is fixed. And then if you do that, and then we can also work on the multiplication on the right-hand side, and then we'll go over that step by step. Right, we have 8 minus 4 squared. So whenever you have in part of expression in a parentheses, then we take care of that first. So you have 4 plus 4 squared. And then 4 squared is basically 4 times 4. So you have 4 plus 4 times 4 equals to 4 plus 16, which is 20. So problem solved. All right, so one rule of thumb is that if you have anything in the parentheses or absolute value signs, then you take care of that part first. But if you have a separated portion from the parentheses, then you can handle that first as well. That's totally fine. And then let's check out other examples. We're being clear about the rule for order of operations, right? So we have 20 minus 3 times 5 minus 7 times 4 minus 2. All right. We're seeing an operator, the inner operator, the parentheses. So we have to take care of the calculation in it. I'll show you step by step. The most inner parentheses or absolute value signs are the one to take care of first. 4 minus 2 equals to what? Equals to 2. Right. Once you get it done, you can remove the parentheses. All right. Next, we have to take care of the expression inside the absolute value sign. Right. Now, let me show you step by step again. Maybe a highlighter will help better. All right. So we have that portion inside the parentheses. We take care of that calculation. And next, we have that portion inside the absolute value sign. So we have to take care of the entire calculation until you have a chance to mess with the value of 3 and the value of 20. Right. Make sure you follow the order in this way. So let's do it. We have 20 stays there, and the negative, and then the 3 stays there, and then we'll have 5 minus 7 times 2. And the absolute value sign multiplication is dealt with first. So we have 7 times 2 equals to 14. So inside the region, 5 minus 14 gives you -9. Absolute value of 9 is what? That would be positive 9, right? So we have 20 times 3 times minus 3 times 9. So you have 20 minus 27, and then the final answer would be -7. Problem solved. I'll show you at the end. I'll show you a counter example. So if you have that portion, let's say we have an example with this portion inside the absolute value sign, and then let's say, hey, we are making up our own math by doing this. We have 5 minus 7 and gives you -2, and then we multiply that by 2, and guess what? You get something totally different, which is not quite right either, right? So remember, multiplication comes first, and then the addition subtraction comes next. Okay, right. Make sure you practice more problems like that, and then a counterexample clearly shows you the difference, right? So, well, if you have any assumption in math, you have to remove it as soon as possible, and make sure you learn that language in the right way. All right, that's all I want to cover in this supplemental lecture, and hope that helps. Make sure you practice more, and then I will see you next time.